In the last video, we talked about programs being instructions, but a program isn't just what to do, it's when to do it. To summarize the last video very quickly, a program is just a set of instructions given to a computer, and a computer is just an instruction follower, and it follows those instructions to a T. But how does this work? Do you just throw a bunch of instructions at a computer and see what sticks? Well, in this video, I'm going to focus on a computer's default behavior for following instructions. We give a computer instructions on a basic level using a text file, kinda like this one. Now, there are certain things to look out for, but generally there's a place to tell the computer, hey, start here. And that right here will be the very beginning of the program. The computer will then read one instruction. Let's say, open the door. And with very few exceptions, it will finish that instruction before moving on to the next one. Like, step outside. It's always good to touch grass. For now, assume a computer will not skip anything. I'll cover this a bit more in future videos. Also, for now, it will not do any multitasking. It will not try to open the door and step outside at the same time. And it has no context or intuition. If the computer is looking at and executing opening up the door, it does not know it's in order to go outside. All it knows is that it's opening a door. So again, to sum it up, a computer's default behavior is to fulfill one instruction at a time in order from start to finish. The fact that a computer operates this way is crucial to know because we are in charge of making sure the instructions are given in the correct order. But why does this even matter? Well, let's consider the example of making an egg. What does that process even look like? Well, first we'd probably need to put a skillet on the stove. I'm practicing typing, guys, sorry. And then once the skillet is on the stove, we need to actually be able to cook the egg, so need to make it hot. Then what? Well, you may put oil in and all that stuff, but I can't list every step. So let's just say that the next step is to crack the egg. And then you put the egg in the skillet for some number of minutes, depending on how you like your eggs. Then after that, transfer everything to a plate. Hopefully in this step, you will also turn off your stove, but then get to enjoy your egg. But what happens if you change the order? Well, let's say you move step 3 to be after step 4. Well, a computer doesn't have any context, so it will put an entire egg in the skillet without cracking it. I mean, it won't because it doesn't have arms, but I think you get the point. Now, I'm not sure if you know this or not, but putting a whole egg in a skillet has a slight chance of exploding, kind of like it does in a microwave. But at the very least, it will not cook very well. So 1, don't try this, and 2, that's why the order of instructions given to a computer matters. And these sorts of issues happen all the time. Maybe a number is shown before rounding it instead of after. Or maybe the step to round the number is forgotten completely. But these small things now may turn out to be big problems later. So now you know that programs start at the beginning and follow instructions step by step. Now the path a program follows to execute instructions is what we call a program's flow. By default, that flow is simple and sequential. If you were to map it out, it would be a straight line. And the computer doesn't decide what comes next, it just follows the path that we give it. In the next video, we'll look at how that path can change by making decisions. Thanks for watching. I hope to see you in the next one.